In question 1, we're going to solve this absolute value equation and then check our answers by looking at a graph. Okay, to start with, there are going to be two possible solutions to this equation, where 2x minus 5 is equal to 3, but also where 2x minus 5 is equal to negative 3. Let's write those down. So we have 2x minus 5. It could be 3, but it also could equal negative 3. In absolute value, they both turn into positive 3. Solving these equations are quite similar. I mean, I would start in both of them by adding 5 to both sides. It's nothing different there. My equations become, this one's going to be 2x is equal to 8. And this one is 2x is equal to 2. Again, here it's going to be similar where we divide both sides by 2 in both equations. So we get x is equal to 4, but also x is equal to 1. So these two numbers are solutions. They both are solutions to this equation. Okay, if you want to graph this thing, in place of y1 in your calculator, there's a place where there is a button for absolute value. What you do is you hit, on the left it'll say math, and then what you do is you scroll over once to where it says number, and then you choose the very first option, which is absolute value. In my calculator, when I hit enter, and I'm in place of y1, I see y1 and then a, b, s, open parentheses. You might actually see the absolute value symbol. It's the same thing either way. But on mine, I see this. I'll then type in 2x minus 5, and then I'll close my parentheses. In place of y2, I'm going to put the other side of my equation, which is 3. So I'm going to graph both of these and see what we get. All right, so I started with the absolute value equation. I just wanted to make sure I got those points right. I checked at 1 and 4, it's equal to 3. And then, okay, if I graph y is equal to 3, I'll do that one in green, it came across like this. And I checked this in my table, but these 2 points were at 1 and 4, and they match on both equations. So graphically, both 4 and 1, if you look at 4 and 1, they're the same y value on both graphs. All right, let's try this again in question 2. To solve this absolute value equation, I'm first going to ignore the absolute values and just say, okay, where's x plus 2 equal to 2x minus 5? This one's pretty easy to solve. I would start by, I guess, subtracting x from both sides. And then I'm going to add 5 to both sides. And I get a solution. I get that x is equal to 7. But again, there's going to possibly be the second solution here. What I'm going to do is let one equation equal the negative of the other. So it's really similar to what I did up here. Left everything alone, just ignore the absolute values. Then I let the left side equal the negative of the other side. And that trick is going to work here too. This is the second equation. Where is x plus 2 equal to negative 2x minus 5? So to solve this equation, I will distribute the negative. And when I solve this for x, I guess I'll start by this time adding 2x, which gives me 3x plus 2 is equal to 5. I'll then subtract 2, and I get 3x is equal to 3. Dividing both sides by 3 gives me that x is equal to 1. All right, but this is where things are going to get difficult in terms of looking at our graphs. I want to check it the same way. I'm going to do that by letting y1 equal the left side of the equation, which is the absolute value of x plus 2. Now the other side is just going to be another absolute value equation. It's not going to be a horizontal line. So that's going to be y2 is equal to the absolute value of 2x minus 5. All right, I'm going to put those in my calculator and then graph it on the xy plane. All right, so here's the first equation, the absolute value of x plus 2. I noted that at both 1 and 7, it took on a value of 3 and 9. All right, so now I'm going to graph in the absolute value of 2x minus 5. All right, and here is my sketch. All right, so I checked that they're both equal at x equals 1 and 7. So in my table, all right, since they're equal here and I get 1, and they're equal here and I get 7, I know my two solutions are in fact correct. One was there, and one was there. In question 3, let's do the same thing. I want to solve this absolute value equation and then sketch a graph of the two graphs. So here my equations are going to be 3x minus 4 is equal to 8 minus 3x. So if I solve this one, I'm going to add 3x to both sides. So I get 6x minus 4 is equal to 8. I'll then add 4 to both sides, and that gives me 6x is equal to 12, dividing both sides by 6. Gives me that x is equal to 2. Now let's see what happens if we try to solve our second equation. So that second equation is going to be, where's 3x minus 4 equal to the negative of 8 minus 3x? Okay, in this one, I get 3x minus 4 is equal to, by distributing the negative, I get negative 8 plus 3x. My first step this time is going to be to subtract 3x from both sides, and I notice there's a problem. When I do that, I get negative 4 on the left, I get negative 8 on the right, and these two things are not equal. All this means is this equation only has one solution, and that solution is that x is equal to 2. When you try to solve the other equation, the x's cancel. So it is possible that you can have an absolute value equation with just one solution. I want to see why by graphing both of these equations. So I'm going to, in place of y1, put in the absolute value of 3x minus 4, and in place of y2, I'll put the absolute value of 8 minus 3x. I'm going to graph both of those and see what we get. So this was the absolute value of 3x minus 4. And then when I graphed in the other one, something like this. That was the equation. So again, I can see that they are equal at this point right here, which is x is equal to 2. So I know that my equation that I solved is correct. But the reason there isn't a second solution is that this part and this part of the graph might not look that great on my sketch, but on my graphing calculator, I can see these two lines are parallel. They'll never meet again. And then the same thing happens on this side. This line and this line are parallel to one another, meaning there could never be a second point of intersection. So this is what happens when your equation has one solution graphically. They equal at one point, but then the rest of the equations are parallel to one another. For question 4, to solve these inequalities, we're going to use our previous work. So A and B are really similar, but they're going to refer back to question 1. So let's note that here. We're going to use the graph from problem 1. For these two, we're going to use the graph from problem 2. And then this is the one we just looked at in problem 3. So we're going to use the graph from 3. So I'll put that on another slide. For part A, there's no algebra to do. It's just like, okay, here are the graphs. I just have to know where is this graph lower than this graph. And I can see that pretty easily. For part A, this is the part of the absolute value that is less than 3 because it's below it. So our job is to then, okay, what are the x values for this portion of the graph? So for part A, this is lower than 3. That's everything from 1 to 4 and not including either because there's no equal sign on this inequality. So here's how you could record your answer. You could say 1 is less than x is less than 4. All right, for part B, we're now asking where is the absolute value greater than this line? Where is it greater than or equal to 3? Well, here's where it's equal. This is the part that's greater. So therefore, we want the x values that are on the outside of those two numbers. So one way you could record your answer for part B is like this. You could say x is less than or equal to, that is x is less than or equal to 1, or x is greater than or equal to 4. And that's the answer for question 4. All right, C and D could be a little bit more difficult to see, but let's start with this one. All right, so here's the graph of x plus 2. I want to know, where is it bigger than the green graph, which is 2x minus 5. Okay, I know where they're equal. That was at 1 and 7. And this is the portion of the graph where x plus 2 is above the absolute value of 2x minus 5. Therefore, I want the stuff that's between those two values. My answer is everything from 1 to 7. And I'm not including either of those points because there's no equal sign on this inequality. Okay, let's look at this here. All right, x plus 2, okay, less than or equal to the absolute value of 2x minus 5. All right, so again, here's x plus 2. Here's the absolute value of 2x minus 5. Okay, this time, this is where the absolute value of x plus 2 is less than the absolute value of 2x plus 5. That's referring to these x values. Likewise, this is where x plus 2 is less than 2x minus 5 in absolute value. So we're talking about the x values to the left of 1. Therefore, my answer is going to be x is less than or equal to 1, or we can say x is greater than or equal to 7. And for this one here, where is the absolute value of 3x minus 4? That's this. Where is that less than the absolute value of 8 minus 3x? Well, here's where they're equal. They're equal at 2. And the red graph, it's lower than the green graph if we're talking about this portion of the graph. That is everything that is to the left of 2, and we're not including it, so my answer is x is less than 2.